The universe is vast beyond comprehension, an endless expanse of stars, galaxies, dark matter, and cosmic silence. Yet the true mystery lies not in its scale, but in its nature. What is this place we exist in? What are its boundaries, if any? Why is there something rather than nothing? These are not just questions for physicists or philosophers. They are the quiet riddles that hum in the background of every human mind. We are floating on a fragile sphere, spinning through the void, warmed by a single star among billions. And somehow, despite the cold indifference of space, we think, we wonder, we question. But the more we uncover, the deeper the mysteries become. Every scientific breakthrough only seems to pull back the curtain on an even stranger theater of existence. This is not a journey of answers. It is a descent into paradox. In this script, we will explore 20 of the universe's most profound and unsettling mysteries, each one a doorway into the unknown. These are not mere curiosities. They are the deep fractures in our understanding of reality. Time that doesn't behave as it should. Matter that seems to know when it's being watched. Energies that have no explanation. Consciousness that may be shaping the cosmos itself. You won't find closure here. What you will find are carefully unraveled paradoxes, each one inviting you to sit quietly with the unknown. To sleep perhaps, but not to forget. To rest your body while your mind wanders the edges of reality. These are the questions that have no end. The thoughts that haunt astronomers, physicists, mystics, and thinkers. This is the universe, not as we wish it to be, but as it truly is. Beautiful, terrifying, and impossibly strange. Let the journey begin. Imagine the universe as a great mind, an ancient intelligence holding the memory of every atom, every star, every moment that has ever existed. But here lies the paradox. If the universe remembers everything, then why does it appear to remember nothing? Why does the cosmos expand forward without ever looking back? This is the paradox of cosmic memory. The contradiction between a universe built on cause and effect, where the past determines the present, and a reality that seems to be forgetting itself as it unfolds. Every moment in time, every particle interaction, every cosmic event is part of a grand causal chain. From the formation of galaxies to the flicker of neurons in your brain, everything you experience is a result of countless prior events. This dependency on the past implies that the universe carries some kind of memory, a record of what has come before. And yet, the observable universe is indifferent to the past, constantly changing, expanding, and moving toward entropy. Information, once lost, is thought to be gone forever. But is that really true? In physics, there's a principle known as unitarity, which suggests that information in a closed system is never truly destroyed. According to quantum theory, the evolution of a system is reversible in time, meaning, in theory, you could reconstruct the past from the present state. So, if unitarity holds at a universal scale, the universe must still contain every bit of information it has ever held. Somewhere, somehow, the imprint of every thought, every planet, every star that collapsed into a black hole still exists. But this brings us to the heart of the paradox. If the universe remembers everything, why can't we find those memories when a black hole consumes matter? It seems to erase the information it contained. The black hole information paradox arises here. According to classical physics, that information is lost forever. But quantum physics says it must be preserved. This contradiction suggests a universe in which memory is both preserved and erased, where everything leaves a trace, but the traces are inaccessible, hidden behind veils of space-time, or encoded in patterns we cannot yet decipher. Even on a cosmological level, as the universe expands and galaxies accelerate away from each other, entire sections of the cosmos are receding beyond our observational horizon. Light from those distant galaxies will never reach us. To us, they may as well not exist. Their stories, their structures, their entire history, lost to us, even if they still carry the imprint of the universe's memory. We are watching the universe forget itself in real time, but it goes deeper. The cosmic microwave background, the afterglow of the Big Bang, is thought to be the earliest memory of the universe. It's a soft whisper from when everything began, an echo of creation, and yet it tells us almost nothing about what came before. Was there something before the Big Bang, another universe, a prior cycle? These questions remain unanswered. The oldest memory we can access is still shrouded in uncertainty. Some theorists believe that the memory of the universe is encoded in the quantum field itself. That reality is a vast entangled network where nothing is ever truly forgotten. Even your thoughts, your actions, the movement of a leaf in the wind, each becomes a thread in the quantum tapestry. But without the ability to decode it, that memory is effectively lost to us. It exists, but cannot be read. So what does it mean to say the universe has memory? And if that memory is inaccessible, is it any different from having none at all? The paradox continues. If time is just another dimension, then past, present, and future coexist, like pages in a book. In that sense, the universe doesn't need to remember anything, because every moment still exists. You reading this, you being born, you in the distant future, they are all part of the same timeless structure. But from your perspective, the past vanishes as quickly as it happens. Memory exists only in your brain. Everything else disappears. In this way, you could say you are the universe's only memory of itself, a brief flicker of awareness, recalling fragments of a vast unfolding mystery. And when your memory fades, what remains? Does the universe continue to remember through someone else? Or does it all dissolve piece by piece into the silence of space? The paradox of cosmic memory forces us to question the most fundamental aspects of existence. What it means to remember, what it means to forget, and whether time itself is erasing the very evidence of the journey it's guiding us through. Perhaps the universe remembers everything, or perhaps it is simply learning how to forget. You sit beneath the night sky, eyes scanning constellations, light-years-old photons landing softly on your retina. What you're seeing isn't the present, it's a ghost of the past, an echo from distant corners of the cosmos. But this act of observation reveals a paradox more unsettling than distance or time. Does the universe exist without an observer? And if not, who was watching before we arrived? This is the paradox of the observer beyond the stars. It begins with a strange realization. Observation appears to shape reality. In quantum mechanics, particles exist in a state of probability until they are measured. The famous double-slit experiment shows that a photon can act like a wave or a particle, depending on whether it is observed. Without observation, the world seems to exist in a haze of uncertainty. Only when we look does it snap into form. But who or what is doing the observing on a cosmic scale? If nothing exists with certainty until it is observed, then the universe, itself, its stars, its galaxies, its laws, may be dependent on consciousness to take shape. But that raises an impossible question. Who was observing the universe before life emerged? The light from distant galaxies has been traveling billions of years. Many of those galaxies no longer exist in the form we see them. We are witnessing the ghosts of creation, their existence confirmed only now, long after their own destruction. So were they real before we saw them? Or did their reality only crystallize the moment our eyes captured their ancient light? If consciousness is required for observation, and observation is required for reality to take form, then the universe needs an observer. But life is a recent phenomenon. For most of cosmic history, there was no human, no consciousness, only matter, energy, and the vast unfolding of time. Was the universe real during those epochs? Was it undefined? Did it exist in a superposition of possibilities until consciousness appeared to collapse it into reality? This leads to a chilling possibility. Either the universe was not fully real until we arrive to observe it, or there is, and always has been, another observer, something beyond us, watching from the beginning. Religions and mystics have long spoken of a cosmic observer, a divine intelligence, a universal mind, a god, not necessarily in the anthropomorphic sense, but as an infinite awareness, predating creation, giving rise to it through perception. In this view, the universe has always had an observer, not a human one, but a presence so foundational that its gaze brought everything into being. Yet science is hesitant to go that far. Instead, it wrestles with the observer effect in more grounded terms. Some physicists argue that it is not consciousness but interaction, measurement through physical systems, that causes collapse. But even this view doesn't eliminate the mystery. After all, what causes those interactions to resolve probability into actuality? At what point does potential become real? Now consider this. If observation determines reality, and if the universe is expanding beyond our ability to observe it, then vast regions of the cosmos are falling out of reality as they slip beyond our cosmological horizon. The farther something gets, the less observable it becomes. Eventually, it's not just invisible, it's beyond influence. Does that mean it no longer exists in any meaningful way? Is the act of drifting beyond perception a form of cosmic erasure? This paradox echoes through the participatory anthropic principle, which suggests that the universe must be compatible with conscious life because consciousness is required to bring the universe into being. In other words, the cosmos gave rise to observers so that it could observe itself. But if this is true, then we are not merely residents of the universe. We are its mirror, its moment of self-recognition. Without us, it is blind. With us, it sees. And yet, there's another possibility, one that takes the paradox even further. What if observation does not require life at all? What if the universe is its own observer? What if, in some unimaginable way, every quantum fluctuation, every collapsing wave function, every entangled particle is the cosmos watching itself? Not through eyes, not through awareness as we know it, but through the silent unfolding of its own laws. In that case, we are not the first observers. We are not the origin of awareness. We are a continuation, a flowering of a process that has been underway since the first spark of light broke through the void. Consciousness may not be an anomaly, but the inevitable result of a universe that cannot help but watch itself. The observer beyond the stars is a paradox that unsettles the very notion of reality. If the cosmos needs an observer, then who was there to witness its birth? And if it doesn't, then why does observation shape everything we see? Perhaps we are not here to see the universe. Perhaps the universe is here to be seen. Try to imagine the edge of the universe. Not metaphorically, but literally. a place where space itself ends. A cosmic boundary where existence stops and non-existence begins. Now try to picture what lies beyond that edge. Can you see it? Can you even conceive of it? If the universe has a boundary, then what is outside that boundary? If it has no boundary, how can something infinite still be expanding? This is the phantom edge of the universe, a paradox that stretches the human mind to its limits. We are wired to understand beginnings and endings, locations and borders. But the universe defies those instincts. It has no center, no edge, no reference point. It expands everywhere and nowhere all at once. Astronomers often describe the universe not as expanding into space, but as space itself expanding. Galaxies aren't flying through space like fireworks. They are being carried apart by the stretching of space-time itself. But this raises a haunting question. What is space expanding into? If the fabric of reality is stretching, is there a larger fabric beyond it? A higher dimensional realm? Or does beyond simply stop making sense? Some theories propose that the universe is finite but unbounded, like the surface of a sphere. If you travel in one direction long enough, you eventually return to your starting point. But now imagine that sphere in 3 dimensions. There is still a surface, a shape, a volume. So what is it floating in? If the universe is a hypersphere, what lies beyond its curvature? Cosmologists suggest that the observable universe, the part we can see, is just a bubble within a much larger reality. But this opens the door to another possibility, the multiverse. Perhaps our universe is one of countless others, each with its own laws of physics, separated by vast gulfs of nothingness. But even if that's true, the question persists. What contains all these universes? What holds the multiverse? What contains the container? We find ourselves lost in infinite recursion, chasing the edge of existence with tools not designed to find it. Our mathematics can describe curved space, open universes, closed geometries, but none of these concepts give us a tangible sense of a boundary. The universe, it seems, may be edgeless, but finite, or infinite with no external context. And yet, the illusion of an edge haunts us. In every map, every model, every artistic rendering of the cosmos, we draw borders. We depict the edge of the observable universe as a sphere, an outer shell of cosmic microwave background radiation, the farthest light we can detect. But that's not an edge of reality. It's just a limit of perception. Beyond that sphere, the universe continues. It could go on forever, or it could fold in on itself. We simply don't know. And here's where the paradox intensifies. Even if we could reach the edge, how would we recognize it? What would a boundary of reality look like? Would we hit an invisible wall? Would time stop? Would space unravel? Or would we simply loop back, trapped in a cosmic Mobius strip with no beginning or end? The phantom edge is phantom not because it isn't real, but because it refuses to be found. It eludes definition. It mocks our understanding of inside and outside, of here and there. It suggests that perhaps space is not something we are in, but something that is in us, an emergent quality of the universe's rules, not a container we can escape. Some theories in quantum gravity and string theory suggest that space itself may be an illusion, a derived phenomenon from deeper structures like entangled quantum information or vibrating multidimensional strings. If space is not fundamental, then the idea of an edge becomes meaningless. There is no outside, because outside is a human concept, not a physical truth. And yet, the question won't go away. The paradox of the phantom edge leaves us suspended in cognitive limbo. If we say the universe is infinite, we cannot prove it. If we say it has an edge, we cannot reach it. And if we say it has neither, we are left with abstractions too strange for the mind to hold. Maybe the edge of the universe is not a place, but a threshold of understanding, a soft boundary between what we know and what we are not yet equipped to imagine. Maybe what lies beyond is not space, but something we do not have words for, a realm beyond geometry, beyond matter, beyond the constraints of logic. Or maybe the true edge is right here, in the part of your mind that is trying and failing to conceive it. In 1965, a faint hiss was detected by two scientists at Bell Labs. At first, they thought it was interference, perhaps pigeon droppings on the antenna, but after cleaning it thoroughly and finding no change in the signal, they realized they had stumbled upon something far more profound, the oldest light in the universe. What they discovered was the cosmic microwave background radiation, an afterglow of the Big Bang still echoing through the cosmos. But here's the strange part. This light is everywhere. No matter where you look, it's there. It's uniform, consistent, and comes from all directions. It is, quite literally, the universe whispering its own origin story. And yet, this whisper presents a paradox, because the uniformity of this light shouldn't exist. This is the paradox of the light that shouldn't exist. The cosmic microwave background, CMB, is so smooth, so evenly distributed, that it seems to imply a level of coordination and communication across the early universe that should have been impossible given the known speed of light. The early universe was hot, dense, and rapidly expanding. According to the standard model of cosmology, regions of the universe that are now billions of light years apart were never in contact with each other. They couldn't have exchanged information, let alone reach a uniform temperature. And yet, when we observe the CMB, these vastly distant regions have exactly the same temperature, to within 1 part in 100,000. How can parts of the universe that have never spoken to each other be so perfectly synchronized? It's as if distant corners of the cosmos had a secret meeting before the laws of physics were written, agreeing on the temperature they would all adopt. This mystery led to the development of the theory of cosmic inflation, a brief period just after the Big Bang in which the universe expanded faster than the speed of light. According to this idea, all parts of the universe we now see were once close together, sharing information and energy. Then, in a tiny fraction of a second, space itself ballooned outward, carrying those connected regions far apart. This would explain the smoothness of the CMB. But inflation, while elegant, introduces mysteries of its own. What triggered it? Why did it stop? Why is the energy responsible for it still hidden? And if space can expand faster than light, does that violate the ultimate speed limit set by relativity? Worse still, inflation may not have stopped everywhere. Some theories suggest it is eternal, that inflation continues in other parts of the universe, forever creating new bubbles of reality, each with its own physics. If true, we are just one island in a vast, unknowable multiverse. But this explanation, while intriguing, doesn't resolve the paradox. It only pushes it farther from reach. Then there's another enigma buried in this light. Tiny fluctuations in the CMB, minute differences in temperature, are not random. They follow a specific pattern. Some scientists believe they may even contain imprints of gravitational waves from the earliest moments of existence. Others speculate they hold signs of physics we do not yet understand. Echoes of other universes, perhaps. or messages from a pre-Big Bang cosmos. And if that weren't, strange enough, there is an eerie asymmetry in the CMB, a subtle cold spot, a preferred direction, a great axis that some researchers have called the axis of evil, not because it's malicious, but because it defies the assumption that the universe is the same in all directions. This anomaly remains unexplained. So we return to the original paradox. The universe is filled with ancient light, but that light should not be so uniform. It should not be whispering the same story in every direction, with such perfect clarity across distances that could never have been connected, unless, of course, our assumptions are wrong. Unless space, time, and causality themselves are illusions, constructs of a deeper, hidden layer of reality. Perhaps the uniformity of this light is not a coincidence, but a clue, a message, a glitch in the simulation, or the fingerprint of a universe that is not random at all, but deeply ordered in ways we cannot yet comprehend. The light that shouldn't exist is not just a relic of the past. It is a silent paradox glowing all around us, quietly defying our understanding. It asks no questions. It offers no answers. It just shines, and we are left to wonder what it means. When we gaze into the night sky, we are not seeing the present. We are looking back in time. The light from distant galaxies takes millions, even billions of years to reach us. In this sense, the telescope becomes a time machine, revealing the ancient history of the cosmos. But with this awe-inspiring ability comes a haunting question. What if, in looking out, we are also looking in? This is the paradox of the mirror of distant galaxies, the eerie possibility that the universe is, in some way, reflecting us back to ourselves. Not just metaphorically, but literally, that the very structure of space, light, and perception is folding reality in on itself. At first glance, this sounds like poetic mysticism, but the paradox has roots in real astrophysical observations. One of the most perplexing ideas in cosmology is that space might be curved in such a way that light could travel around the universe and return to its point of origin, much like how traveling far enough in one direction on Earth eventually brings you back home. If this is true, then some of the galaxies we see in the night sky might not be separate galaxies at all. They might be images of our own galaxy, seen from an unfathomable distance, distorted and delayed by billions of years. Imagine that. A mirror so vast, it reflects not just light, but entire galactic epochs. We may be seeing versions of ourselves, our galaxy, our local group of stars, circling back through cosmic curvature, so old and redshifted that we no longer recognize them. This isn't just a thought experiment. It's a theoretical implication of a closed or multiply-connected universe, in which space is not infinite but loops back on itself. In such a topology, photons could traverse the cosmic structure like sound echoes in a dome, creating mirrored and repeated images of distant objects, including potentially us. But here's the unsettling part. If we are seeing ancient versions of ourselves, then we are seeing a version of time that is no longer real, a frozen reflection of a past that cannot interact with us, yet exists simultaneously in our perception. It's as if reality itself is laced with optical illusions, a cosmic funhouse of echoes and images that never belonged to someone else. They were always our own, yet there's more. Some researchers have speculated that anomalies in the distribution of galaxies and cosmic structures could hint at these reflections, patterns that repeat, alignments that defy randomness, signals that suggest the possibility of light paths looping back in ways we have not yet understood. If we ever do identify A galaxy that perfectly matches our own in structure and evolution. Could it be that we are finally seeing ourselves, not in a mirror made of glass, but in one made of time, light, and space? This leads to a deeper question. If the universe reflects us, can it also observe us? And if so, what does it mean to exist in a reality that watches itself from every angle, distorted and delayed, yet infinitely present? The mirror of distant galaxies is a paradox that asks us to consider whether the farthest reaches of space are not foreign, but familiar, whether the deepest parts of the cosmos are not beyond us, but within us. It reminds us that time, space, and identity may be woven together in ways that blur all distinctions between self and other, past and present, here and there. And as we continue to peer deeper into the void, we may discover that what stares back is not the unknown, but an ancient version of ourselves, long gone, yet still shining. For decades, we have listened. Radio telescopes scan the sky day and night, reaching deep into the cosmos for a signal, any signal, that might hint at intelligent life beyond Earth. And yet, across all the frequencies, in every direction, there is silence. An eerie, unbroken silence that stretches across the stars. This is not just a mystery, it is a paradox. The silent intelligence paradox asks, if intelligent life is not unique to Earth, and the universe is unimaginably vast, then where is everyone? This question, famously framed as the Fermi paradox, has baffled scientists, philosophers, and dreamers alike. Given the age and scale of the universe, there should have been plenty of time for intelligent civilizations to rise, spread, and make their presence known. The Milky Way alone contains over 100 billion stars, many with planets in the habitable zone, and yet, nothing. One possible explanation is that life is rare. Perhaps the emergence of intelligent, technological beings like us is extraordinarily improbable. Maybe Earth is not the rule, but the exception, a lonely miracle adrift in cosmic emptiness. But this leads to uncomfortable implications. If life is so rare that we are alone, then what makes us so special? And if intelligent civilizations inevitably destroy themselves before reaching the stars, is our own silence a foreshadowing of our fate? Another possibility is that alien civilizations are out there, but they are choosing not to communicate. They may be observing us quietly, waiting for us to mature. This is the zoo hypothesis. The idea that Earth is like a cosmic wildlife preserve, and we are being studied from afar. But if that's the case, why not leave a trace, a whisper, a signal just clear enough to let us know we're not alone? Some suggest that we are listening for the wrong things. Our attempts at communication are based on human logic, language, and technology. What if other civilizations communicate in ways we cannot detect or even imagine? What if they use quantum entanglement or gravitational waves or forms of thought-based transmission beyond our current science? There is also the haunting idea that civilizations may have emerged and vanished long before us. The universe is nearly 14 billion years old. Human beings have been around for just a blink of that timeline. Perhaps others rose, flourished, and fell billions of years ago, leaving behind only the silence of extinction. We may be late to the party, walking into a vast hall where the music has already stopped. But the paradox deepens when we consider our own behavior. We are listening for alien signals, but how loudly are we speaking? Earth has only been broadcasting radio waves for about a century, a mere moment in cosmic terms, and those signals weaken as they travel. Beyond a few light years, even our most powerful broadcasts become indistinguishable from background noise. So perhaps every intelligent civilization listens, but none speak, each waiting for someone else to break the silence, each afraid to reveal themselves first. The universe then becomes a room full of sentient beings, all quietly waiting for someone to say hello. But what if the silence isn't out there? What if it's in us? We assume that we are capable of recognizing intelligence when we find it, but intelligence may take forms we do not recognize. Structures in interstellar clouds, patterns in dark matter, or even vast simulations beyond space and time. If we lack the senses or the understanding to perceive these forms, we might be surrounded by intelligence without ever knowing it. The silent intelligence paradox challenges our assumptions, not just about the universe, but about ourselves. It forces us to question the limits of our perception, the nature of life, and the possibility that silence is not absence, but camouflage. Perhaps the stars are full of watchers. Perhaps their silence is the answer. Gravity is a force so familiar, so constant, that we rarely question it. It keeps our feet on the ground, binds planets to stars, and sculpts the very structure of galaxies. But in the vastness of the cosmos, gravity begins to behave in ways that defy explanation. In places where there should be little or no matter, gravity persists, sometimes stronger than it should be. And in that unseen pull lies a paradox. This is the gravity without mass dilemma, a cosmic contradiction where gravity appears without enough visible mass to explain it. According to Newton and Einstein, mass and energy create gravity. The more mass you have, the more gravitational pull you exert. But when astronomers observe distant galaxies, they find something strange. The stars within them are moving too fast. Based on the amount of visible matter, those galaxies should have torn themselves apart, yet they hold together, bound by a force that seems to come from nowhere. This mystery has led to one of the most significant concepts in modern astrophysics: dark matter. A form of matter that does not emit, absorb, or reflect light. We cannot see it. We cannot touch it, but we infer its presence from its gravitational effects. Scientists estimate that dark matter makes up about 85% of the matter in the universe, and yet it has never been directly detected. We are left chasing a ghost, a massive invisible presence that shapes the cosmos, but refuses to reveal itself. But here's where the paradox deepens. What if there is no dark matter? What if gravity itself is not what we think it is? Some physicists propose that our understanding of gravity may be incomplete. Perhaps Einstein's general relativity breaks down at large cosmic scales. Maybe gravity behaves differently in regions of low acceleration or over intergalactic distances. These ideas have given rise to alternative theories like modified Newtonian dynamics, MOND, or emergent gravity, which suggest that what we perceive as extra gravitational force may not require unseen matter, but a new law of nature. And yet, these alternatives face challenges of their own. They explain some observations, but fail in others. Dark matter, despite its invisibility, still offers the most consistent model for explaining galactic behavior, cosmic microwave background patterns, and large-scale structure formation. Still, the discomfort remains. We are basing the most fundamental understanding of the universe on something we cannot detect. Consider the implications. The universe behaves as if there is mass where there is none. Entire galactic halos, vast spheres of gravitational influence, are filled with something we cannot see. Galaxy clusters bend light around them in a phenomenon called gravitational lensing, revealing the gravitational fingerprints of unseen mass. But we're forced to ask, are we seeing real mass or just the echo of gravity from some unknown source? If dark matter is real, what is it made of? Wimps? Axions? Sterile neutrinos? If it's not real, what does that mean for our entire framework of physics? Are we watching shadows on the cave wall, mistaking the shape of an unknown force for something it's not? The gravity without mass dilemma is a crack in the foundation of cosmic understanding. Either an invisible, undetectable substance dominates the universe, or our deepest theories about gravity are wrong, and perhaps the most unsettling possibility is that both are true, that the universe is stranger than either explanation allows, and we are still in the early stages of deciphering its rules. So when you look up at the stars and feel the pull of the earth beneath your feet, remember this: the same force that holds you here is at work holding together galaxies, often in ways we still don't understand. Gravity is everywhere, but its source may be nowhere. In the early days of the universe, moments after the Big Bang, a sea of particles burst into existence: protons, neutrons, electrons, photons. But among these was something else: antimatter. For every particle of matter, there was an equal and opposite antiparticle. When matter and antimatter meet, they annihilate, leaving behind pure energy. According to the laws of physics, the universe should have created equal amounts of both. So here's the mystery. Where did all the antimatter go? Why is the universe dominated by matter, when it could have just as easily been reduced to a formless ocean of energy? This is the paradox of vanishing matter, a cosmic imbalance between matter and antimatter, so subtle, yet so fundamental, that it determines why anything exists at all. If matter and antimatter had been perfectly equal, every particle in the early universe would have had a twin. They would have collided, cancelled each other out, and vanished into light. No galaxies, no stars, no planets, no people, nothing but radiation. Yet here we are, made entirely of matter, walking in a universe that somehow escaped perfect annihilation. Physicists refer to this mystery as baryon asymmetry, the unexplained surplus of matter over antimatter. But the problem is more than just a surplus. It's the fact that the universe chose a side, even though the known laws of physics don't clearly favor one over the other. Some theories suggest that in the earliest moments of the universe, a slight imbalance, one extra particle of matter for every billion particles of antimatter, tipped the scales. When the annihilation occurred, the tiny amount of leftover matter formed everything we see today. But why did that imbalance exist at all? One possible explanation lies in the violation of a principle called CP symmetry, the idea that the laws of physics should remain the same if you flip matter into antimatter, C, and reverse the spatial coordinates, P. Experiments have observed slight CP violations in certain particles, like kaons and B mesons, but these are not nearly enough to explain the scale of matter's dominance. The asymmetry remains a riddle, hanging like a flaw in the cosmic blueprint. Others have proposed that during a phase transition in the early universe, the vacuum itself changed its structure in a way that favored matter, or that unknown forces, perhaps tied to undiscovered particles, tilted the balance. Some even speculate that entire regions of the universe might be made of antimatter, separated from us by vast stretches of normal matter and void. But if that were true, the collisions between these regions would release colossal energy, and we would see gamma rays lighting up the sky. We don't. The universe appears overwhelmingly matter-based. Antimatter seems to have vanished, but not entirely. We can create antimatter in laboratories. In particle accelerators, high-energy collisions produce positrons, anti-electrons, and antiprotons. In fact, medical devices like PET scanners rely on positrons. So antimatter is real, accessible, and obeys the same fundamental rules. But in nature, it's astonishingly rare. Where did it go? Could it be hiding? Locked in dark sectors of the universe we cannot see? Could antimatter be bound in exotic particles or exist in alternate dimensions, interacting only through gravity or other unknown forces? The paradox runs deeper still. If antimatter did dominate another part of the universe, how would it perceive us? To it, we would be the strange anomaly. From its perspective, we are the vanishing matter. The paradox of vanishing matter reveals how fragile reality truly is. Our entire existence hinges on a tiny imbalance that should not have occurred. Everything you know, every atom in your body, every breath you take, is the result of a cosmic near miss, an almost complete erasure of existence that failed just enough for stars to form, for planets to coalesce, and for life to wonder why it survived. Maybe the answer lies hidden in the earliest seconds of creation, in the chaos before physics cooled into order. Or maybe it is a question with no resolution, just one more crack in the illusion of understanding. We are the survivors of an ancient imbalance, children of a mystery, born from the matter that should have never existed. The closer we look at reality, the more it begins to dissolve. At the macroscopic level, the universe seems ordered, stable, and predictable. Planets orbit stars, objects fall to the ground, and time moves forward. But zoom in far enough, down, past molecules, atoms, and subatomic particles, and you enter a world so strange, it challenges the very idea of existence. This is the quantum fabric illusion, the paradox that what we perceive as solid, continuous, and real is actually built on a foundation of uncertainty, probability, and nothingness. At the quantum level, particles don't behave like tiny marbles. They exist in states of possibility, known as superpositions, where they can be in multiple places at once. They don't have definite properties until they're observed, and even then, the act of observation seems to alter the outcome. This isn't just philosophical, it's measurable, repeatable, and real. According to the Heisenberg uncertainty principle, you can't know both the position and momentum of a particle with absolute precision. The more precisely you measure one, the less you know about the other. This means that, at the most fundamental level, reality is fuzzy, not due to human error, but as a built-in feature of the universe. And yet, somehow, this chaotic dance of uncertainty gives rise to the world we experience. Solid walls, ticking, clocks, and cause and effect logic. How does this unstable quantum foam coalesce into reliable physical reality? That's where the illusion comes in. Quantum field theory suggests that what we perceive as particles are actually vibrations in invisible fields that stretch across the universe. The electron, for example, is not a tiny sphere, but a ripple in the electron field. Photons are ripples in the electromagnetic field. These ripples interact, tangle, and collapse in ways that appear random, but from them emerge the building blocks of everything we know. But here's the twist. Even the vacuum of space, which we often think of as empty, is not truly empty. It's alive with fleeting quantum fluctuations, particles that pop in and out of existence in unimaginably short intervals. These virtual particles influence the behavior of real particles, shape the universe's expansion, and may even explain phenomena like the Casimir effect, where two metal plates in a vacuum are mysteriously drawn together. So what does this say about the nature of space itself? If the very fabric of the universe is made of fields that are constantly fluctuating, never still, never certain, then space is not a passive backdrop. It is an active, dynamic sea of probabilities. Reality, then, is not built from solid bricks, but from waves, interference patterns, and collapsing probabilities. It is, in a very real sense, an illusion, stable only because of the scale at which we experience it. This leads to a deeper question. Is the universe inherently real, or is it fundamentally information? Some physicists propose that reality is not physical at all, but digital, a projection of information encoded in the fabric of space-time. This brings us into the realm of the holographic principle, which suggests that the three-dimensional universe we experience may be a projection of information stored on a two-dimensional boundary. In this view, even gravity emerges from quantum entanglement, a relational property, not a force acting at a distance. And if that's the case, then reality as we know it is not just uncertain. It may be a simulation, a pattern of bits and probabilities generated from a deeper level of abstraction we cannot perceive. The quantum fabric illusion forces us to confront a strange duality. On one hand, we live in a tangible world. We feel, see, touch, and interact with what seems undeniably real. On the other hand, every experiment at the smallest scale reveals that this reality is more like a probabilistic mirage, a stable illusion born of unstable laws. So, what are we really standing on? What are we really made of? Particles that aren't really particles, fields that flicker, empty space that isn't empty, observation that defines reality, and a fabric that feels solid until you look too closely. Maybe the truth is this: we are walking on a tapestry woven from nothing, and yet somehow it holds everything. We often imagine consciousness as a flicker within the skull, a byproduct of neurons firing, a curious side effect of evolution. We treat it as something local, something small, something separate from the universe around us. But what if that assumption is wrong? What if consciousness isn't confined to the brain, but is instead a fundamental aspect of the universe itself? This is the conscious cosmos hypothesis, a paradox that challenges the boundary between mind and matter, between observer and observed, between the inner world and the outer cosmos. In modern science, we are taught that consciousness arises from complexity, as matter organizes, first into molecules, then into cells, then into neural networks. Somewhere along the way, awareness emerges. But this view leaves a glaring question unanswered. How does subjective experience arise from purely physical processes? How do atoms and electrons, which are not conscious on their own, somehow give rise to the vividness of inner life? This is known as the hard problem of consciousness, and it has resisted explanation for decades. Some philosophers and physicists have begun to ask a more radical question. What if consciousness didn't emerge from matter at all? What if matter itself emerged from consciousness? This flips our worldview entirely. Rather than the universe giving rise to awareness, awareness gives rise to the universe. This isn't a spiritual metaphor. It is a real and growing line of inquiry in quantum physics, cosmology, and philosophy of mind. One of the most intriguing clues comes from quantum mechanics. In countless experiments, the act of observation appears to collapse a quantum wave function, transforming a cloud of probabilities into a single, defined outcome. But what is an observation, and why does it seem that a conscious observer is required for this collapse to occur? If observation shapes reality, then consciousness plays an active role in creating the universe we experience. This has led some to suggest that consciousness is not just involved in the universe, it is woven into its fabric. The conscious cosmos hypothesis proposes that awareness is fundamental, just like space, time, and energy. It doesn't arise. It's always been there. Not necessarily as human-like thought, but as a field or presence. Some even describe it as a kind of cosmic awareness, an intelligence not confined to brains, but embedded in the very essence of being. Eastern philosophies have long held a similar view. Traditions like Advaita Vedanta, Taoism, and certain schools of Buddhism describe consciousness not as an individual trait, but as the ground of all existence. In these views, the separation between the observer and the observed is illusory. Everything is one field of knowing, dreaming itself into form. Modern theories like panpsychism echo these ideas, suggesting that all matter, even down to the level of particles, possesses a degree of consciousness, not in the way humans experience it, but as a kind of proto-awareness. According to this view, the universe doesn't become conscious. It is conscious at every level. But this introduces a paradox. If consciousness is everywhere, why does it feel so rare? Why does it seem to bloom only in highly complex systems like human brains? And if the universe is conscious, what is it thinking? We don't know. We may never know. But the implications are profound. If the universe is conscious, then our own minds are not isolated islands. They are expressions of the cosmos, momentary focal points through which it experiences itself. Your thoughts, your awareness, your sense of being may be not separate from the universe, but the universe becoming aware of itself. In this way, we return to a kind of cosmic intimacy. The stars, the void, the quantum fields, all are not out there, but part of the same conscious field that gives rise to your own awareness. The divide between self and world begins to blur, and in that blur, something beautiful emerges. The idea that you are not in the universe. You are the universe, briefly awake, briefly asking questions about its own nature. The conscious cosmos hypothesis invites us to reconsider not just what the universe is, but what it means to exist at all. It offers no easy answers, only the possibility that what we call mind and what we call matter are two sides of the same unfathomable mystery. Maybe the cosmos isn't cold, blind, and indifferent. Maybe it is dreaming. Every story has a beginning, or so we think. The universe too is said to have begun with a single moment, the Big Bang, a colossal eruption from a point of unimaginable density, birthing time, space, and matter in one cataclysmic flash. But the closer we look at this so-called beginning, the more it slips through our fingers. Because if the Big Bang was the start of everything, what came before it? This is the paradox of infinite beginnings. The contradiction that emerges when we try to assign a first moment to time itself, a starting line to a race that includes the runner and the track. If time was created in the Big Bang, then the concept of before becomes meaningless. Yet our minds can't help but ask, what was there before anything was? Our logic breaks down here. We are so deeply embedded in linear time that we can't conceive of existence without it. Cause follows effect. Moments unfold. Things begin and end. But the Big Bang presents a scenario in which time itself begins, leaving no room for a prior state. It's like trying to imagine a location north of the North Pole. There is no more north beyond it, and yet, the idea of something coming from truly nothing is equally incomprehensible. Can there be a moment when absolutely nothing existed? Not even time, not even space. And then, suddenly, something. From where? From what? This tension has fueled alternative cosmologies, Some propose a cyclic universe, one that expands and contracts in eternal rhythm. In this model, the Big Bang wasn't the beginning. It was simply the latest chapter in an endless sequence. Before our universe was another, and before that, another still. No true origin, just a cosmic heartbeat echoing through eternity. Others suggest quantum fluctuations in a vacuum gave rise to our universe, a random event in a quantum foam of potentiality. But even then, we must ask, where did that vacuum come from? Where did the rules governing quantum mechanics originate? String theory offers another idea, that our universe may be the product of a collision between higher dimensional brains. These membranes exist in a multiverse landscape, occasionally slamming together and triggering Big Bang-like events. But this too leads us down an infinite corridor. What created the brains and the space they float in? Some theories explore the idea of a timeless realm, where all possibilities exist simultaneously. In such a framework, the universe doesn't evolve. It simply unfolds, like a hologram being read by the light of awareness. Time is not fundamental but emergent, and beginnings are illusions, points of reference created by minds embedded in the experience of time. But even that leaves us with the paradox. If beginnings are illusions, why do we experience them so persistently? Perhaps the real issue lies in the nature of questions themselves. The human mind evolved in a world of starts and stops, of causes and effects. Our thoughts are built to trace lines, not to grasp wholes. When we ask about the beginning of the universe, we are applying a linear question to a reality that may not be linear at all. And still, we can't stop asking. The paradox of infinite beginnings is a riddle not just about cosmology, but about cognition. It reveals the limits of thought, the edges of reason. It asks whether some truths are simply inaccessible from within the system that seeks them. And yet, paradoxically, it is that very edge that draws us forward. If the universe had no beginning, how can it exist at all? If it had a beginning, how could that beginning come from nothing? And if something came before it, are we not just shifting the problem further back? We may never find a first cause. We may never answer the question of why there is something, rather than nothing. But in that mystery lies a strange kind of beauty, a sense that existence itself is a miracle so profound, so complete, that it refuses to be explained. Perhaps the universe did not begin. Perhaps it always was. Or perhaps it is beginning now, in every moment, endlessly, and we are simply its latest expression of wonder. When we hear the word void, we imagine a blank expanse, a perfect, eternal nothingness, a place without stars, without air, without time. In our minds, the void is the ultimate emptiness, a canvas before creation. But in modern physics, the void is anything but empty. In fact, it might be the most active, complex, and vital part of the entire universe. This is the paradox of the void that isn't empty, the contradiction that space, when stripped of all matter, light, and heat, continues to teem with energy, fluctuation, and hidden structure. In classical thought, the vacuum was a truly empty space, but quantum field theory has rewritten that idea. According to this theory, even in a perfect vacuum, fields remain. These fields, electromagnetic, Higgs, gravitational, do not disappear in the absence of matter. They continue to exist, and they are never truly at rest. They ripple, flicker, and pulse with quantum fluctuations. Particles spontaneously appear and vanish in what is known as vacuum fluctuation. These are not abstract metaphors. They are real, measurable effects. The Casimir effect, for instance, demonstrates that two metal plates placed closely together in a vacuum will experience an attractive force due to these fluctuations. The vacuum, it turns out, has structure. Worse still, for our classical intuitions, the vacuum may be more than structured. It may be the foundation of everything. According to some physicists, what we perceive as matter, protons, electrons, atoms, is simply a disturbance in the vacuum fields. The particles that make up your body are excitations in a sea of invisible energy. Matter is not a building block added to space. It is a phenomenon emerging from the void itself, and the void may not even be stable. Quantum theories suggest that the vacuum could suddenly decay into a lower energy state, a true vacuum, obliterating everything in the blink of an eye. This idea, called vacuum metastability, means that the universe as we know it may be balanced precariously on a false bottom, one quantum tremor away from erasure. So we are left with a chilling thought. The nothingness we depend on is full of everything. It holds the seeds of creation and the keys to annihilation. It is the background noise of existence and possibly the blueprint of reality itself. Cosmologists believe that dark energy, the force responsible for the accelerating expansion of the universe, may be an inherent property of the vacuum. If that's true, then the empty space between galaxies isn't truly empty. It's filled with a kind of pressure that stretches the very fabric of reality. Even the birth of the universe may have emerged from a quantum fluctuation in an absolute vacuum, a spontaneous burst of energy where nothing once ruled. If space can give rise to energy and energy to matter, then perhaps everything came from nothing, and that nothing is the most active, pregnant condition of all. But this paradox doesn't only challenge our physics, it challenges our philosophy. If emptiness is never truly empty, then what does it mean to be alone? To be still? To be silent? The space between your thoughts, the pause between your breaths, the vast blackness between stars. These are not voids. They are fullness, in disguise. Beneath the illusion of absence lies a mystery so dense with potential that it may be the origin of all that ever was and all that ever will be. The void that isn't empty reminds us that what we overlook may be the source of everything, that silence may contain the loudest truth, that nothingness may be the ultimate something. And in the stillness of the void, the universe continues its quiet, unending creation. Imagine two identical twins. One remains on Earth, grounded in the familiar pull of gravity, the rhythm of clocks, the warmth of daylight. The other boards a spacecraft and travels near the speed of light, darting through the cosmos for what feels like a few years before returning home. When they reunite, the twin who stayed on Earth has aged decades, but the one who traveled, only a handful of years have passed. This is the essence of the twin paradox, a strange and experimentally supported consequence of Einstein's theory of relativity. But when we push deeper into its implications, a more profound version of the paradox emerges, one that doesn't just challenge our understanding of time, but dismantles it entirely. This is the time-bending twin paradox reimagined. At its core, the twin paradox reveals that time is not absolute. It flows differently depending on speed and gravity. The faster you move, the slower time moves for you relative to someone at rest. Near massive objects, gravity warps space-time and stretches time itself. Time, then, is elastic. It bends, dilates, and contracts based on your frame of reference. But here's the twist. If time moves differently for each observer, then what is the true present? When the traveling twin rockets through space, from their perspective, it is the earthbound twin. who experiences strange shifts in time. Both believe they are at rest. Both experience time as moving normally for themselves. It is only in the act of returning, when frames are compared, that the discrepancy is revealed. This isn't just a math trick or a theoretical game. Time dilation has been proven with atomic clocks flown around the Earth in jets. GPS satellites, orbiting high above the planet, must account for both their speed and the lower gravity in space, adjusting their time signals to remain accurate. But if time is relative and reality is dependent on perspective, then what is now? Is there a universal moment that everyone shares? Or is every observer forever trapped in their own private timeline? Let's take this further. What if one twin journeys near a black hole, a place where gravity stretches time to its limit? To the traveler, only hours may pass, but to the twin on Earth, centuries may roll by. The returning twin could arrive in a world they no longer recognize, a future built on ruins, memories, or silence. And now, consider the ultimate question. If time is not fixed, does the future already exist? In the block universe interpretation of relativity, all points in time, past, present, and future, are equally real. Time is not a river that flows. It is a landscape, already there. We, as observers, are merely moving through it. The twin, who travels far into space, isn't aging slower. They're just taking a different path through the temporal terrain. This reimagining transforms the paradox into something stranger. Each twin is not aging at different speeds. They are living in different realities. Realities that only align momentarily before diverging forever. And if that's true, if time is not unfolding, but already laid out, then what becomes of choice, of memory, of the idea that we are moving forward? The time-bending twin paradox. Reimagined reveals a universe where time is not what we think it is, where simultaneity is an illusion, where each being carries their own personal clock through a space-time that shifts with motion and mass. It invites us to wonder, are we truly aging? Or are we just exploring a predetermined landscape, step by step, thinking we are writing the story, when in fact we are reading it? Perhaps the real paradox is not that one twin ages slower than the other. Perhaps it's that both believe they live in the same moment, when in truth, they never really did. The universe we live in is vast, ancient, and ever-expanding. Yet, with all its age and distance, we are told it had a beginning, a moment of explosive birth known as the Big Bang. We look back in time by observing distant galaxies and cosmic radiation, tracing the fingerprints of that origin. But among those fingerprints are subtle patterns, strange alignments, and curious anomalies that whisper a far more unsettling possibility. What if this is not the first universe? This is the paradox of the echoes of a forgotten universe, the idea that our cosmos may carry within it faint, fading memories of a prior existence. A universe that came before, whose remnants still echo through the structure of everything we see. The cosmic microwave background, CMB, is often described as the afterglow of the Big Bang, a relic from when the universe was just 380,000 years old. It blankets the sky in soft microwaves, nearly uniform, but speckled with tiny fluctuations. These temperature variations are believed to be the seeds from which galaxies formed, but not all of them make sense. Some anomalies in the CMB, such as the cold spot or the axis of evil, defy easy explanation. They are statistical outliers, patterns that seem too structured, too organized, too purposeful to be random. Some cosmologists have begun to ask, Are these the echoes of something that came before our universe? One of the more provocative theories that embraces this idea is conformal cyclic cosmology, proposed by physicist Roger Penrose. In this model, the universe undergoes infinite cycles, called aeons, where each Big Bang is not the beginning of time, but the end of a previous universe's life. As the old universe stretches into infinite expansion and entropy, it eventually becomes so smooth and diffuse that time and scale lose all meaning. At that point, it can transition seamlessly, paradoxically, into the next Big Bang. In this view, the universe forgets itself, but not entirely. Some information, some imprint, leaks forward across the cosmic boundary. And those imprints might be visible today, hiding in the CMB. But how can anything survive such a cosmic reboot? Black holes may offer a clue. According to Penrose, as black holes evaporate through Hawking radiation over trillions of years, they eventually vanish. But the information they contain may not be destroyed. It may be released in a form so subtle we cannot yet decode it. And if that information survives the death of one universe, it may seep into the birth of the next. This possibility forces us to rethink the very nature of beginnings. If information can be passed across aeons, then the universe may be learning from itself, evolving across cycles, carrying forward echoes, patterns, and structure. And what we see as the randomness of the early universe may, in fact, be a kind of cosmic memory. But here's where the paradox bites. If the current universe contains remnants of a prior one, then how can we ever know? Any evidence we find must survive not only cosmic expansion, but the entropy and erasure of a prior reality. We are looking for footprints in the ashes of a fire that burned before time began. And if we do find those echoes, what then? Does it mean time is circular? That we have lived and will live infinite lives in infinite worlds? Are we destined to repeat the same patterns endlessly? Or is each cycle unique, learning from the past in ways we cannot fathom? The echoes of a forgotten universe don't scream, they whisper. They live in the cold places, in the background radiation, in the quiet asymmetries of space. We can't hear them clearly, but we can feel their presence, like a song played too softly to catch, but too distinct to ignore. Perhaps the universe never truly forgets. Perhaps we are living in the afterglow of a memory so vast, so old, that even light has not finished telling its story. And perhaps the next universe will remember us, just as we begin to remember something that came before. We often think of the universe expanding like a balloon. Galaxies on the surface drift apart as the balloon inflates, carried away by the stretch of space itself. But this picture, while helpful, conceals a deeper and more puzzling mystery. Because in cosmology, it's not objects moving through space that causes the expansion. It's space itself that is growing, and that leads us into a strange and subtle contradiction. This is the paradox of the expansion that creates space. The idea that the universe isn't expanding into anything, but that expansion is creating the very fabric of existence as it goes. In our daily lives, space is just there. It holds things. It contains us. It feels like a container, a pre-existing stage on which reality unfolds. But in cosmology, that notion collapses. The expansion of the universe is not like an explosion within space. It is the expansion of space itself. There is no outer edge, no background medium into which it grows. Wherever space exists, it expands. And that means new space is being created continuously. But how can something be created from nothing? What is this new space made of? And where is it coming from? Even more strangely, this expansion is accelerating. Distant galaxies are not just drifting away, they're doing so faster over time. The source of this acceleration is known as dark energy, an unseen force or property of the vacuum that pushes the universe apart. We don't know what dark energy is. We just know that it's making space grow faster and faster, stretching reality itself at every scale. And here's where the paradox sharpens. As space expands, it creates more of itself, which in turn allows more expansion. The result is exponential growth, especially in regions of deep emptiness, where gravity isn't strong enough to counteract the stretching. It's a self-reinforcing process, a kind of geometric recursion where nothing births more of nothing, endlessly. But if space is expanding everywhere, why don't we feel it? Why don't atoms, buildings, or solar systems get pulled apart? The answer lies in the strength of local forces. Within galaxies, gravitational binding and electromagnetic forces are strong enough to resist the gentle tug of expansion. It's only at intergalactic scales, between massive clusters of galaxies, that the stretch becomes noticeable. The universe expands between the things it cannot pull together, yet even within that explanation, the puzzle lingers. What does it mean for space to grow? If you double a piece of fabric, you can measure its increase, but with space, you're stretching the ruler as well. The yardstick grows with the fabric. So how can we say anything is expanding at all? It challenges our deepest intuitions. We imagine growth as expansion into something. But in cosmology, there is no outside. The universe does not have an edge. Space doesn't expand into a void. It becomes. This leads to another profound implication. The observable universe is not the whole universe. Because light takes time to reach us and space is expanding faster than that light can travel, there are regions we will never see. Those regions exist, but are forever cut off from us. The horizon of our observable universe becomes a kind of boundary of knowability, constantly receding, endlessly unreachable. So here we are, living in a cosmos that is creating itself moment by moment, not by adding more things, but by adding more nothing. A fabric of space that didn't exist a second ago now exists, filled with potential, governed by laws we barely understand. The paradox of the expansion that creates space asks us to imagine existence not as a static container, but as a living, breathing phenomenon. It forces us to let go of classical metaphors and accept that reality may be built on processes that don't resemble anything in human experience. We are floating not in a space that was always there, but in a space that is being woven under our feet, constantly, silently, eternally, and the loom never stops. In the vast structure of the cosmos, galaxies are not randomly scattered. They are organized into immense filaments, clusters, and voids that span hundreds of millions of light years. On this grand scale, the universe is supposed to be isotropic and homogeneous, meaning it looks the same in every direction, and the distribution of matter is uniform on large scales. But in 2008, something strange was discovered. A group of distant galaxy clusters appeared to be moving together in one direction at immense speed. This motion couldn't be explained by gravity from nearby structures. Something beyond our visible universe seemed to be tugging on them. This is the dark flow enigma, a cosmic paradox where something unseen, something outside the known cosmos, appears to be exerting a measurable influence on matter within it. The phenomenon was detected using data from NASA's Wilkinson Microwave Anisotropy Probe, WMAP. Scientists noticed that clusters of galaxies were all heading in roughly the same direction at over 600 kilometers per second. That direction toward the edge of the observable universe. But here's the issue. the universe shouldn't have any preferred direction. According to the cosmological principle, on large scales, the universe is smooth and directionless. The expansion should be uniform. Galaxies should be moving away from each other, but not drifting in a coordinated flow. And yet, the data suggested otherwise. There was flow, but no apparent cause. What could be pulling entire galaxy clusters across billions of light years? Some scientists theorized that the source of the pull might lie beyond the observable universe. That is, outside the region of space from which light has had time to reach us. If that's true, it means the visible universe is just a small patch in a much larger reality, one that continues beyond our cosmic horizon. But how can something beyond the limits of observation affect what we see? That's the heart of the paradox. If this dark flow is real and not a misinterpretation of data, it would imply the presence of massive structures or gravitational anomalies outside our observable bubble. These might be primordial formations left over from a previous universe, supermassive clusters, or even the gravitational influence of another universe in a multiverse landscape. Such ideas sound fantastical, but they stem from serious attempts to reconcile observation with theory. If our universe is just one bubble in a cosmic foam, and other bubbles exist nearby, their gravity could potentially affect ours. This would violate our most basic assumptions about cosmic isolation and challenge the very idea of a self-contained universe. Other explanations have been proposed. Perhaps the data was flawed. Perhaps the measurement technique introduced bias. More recent analyses from the Planck satellite have cast doubt on the original dark flow claim, but the controversy remains unresolved. Some studies continue to find signs of large-scale flow, others don't. The debate is ongoing. Still, the paradox endures, not just because of the data, but because of what it would mean if it were true. It would mean that the observable universe is not a complete story. It would mean that causality can stretch beyond the limits of light, that something we cannot see is shaping our cosmic destiny, and it would mean that our understanding of space, time, and the boundaries of reality is profoundly incomplete. The dark flow enigma is a reminder that the edge of the observable universe is not the edge of existence, that what we cannot see may still touch us, and that the forces shaping our world may originate in places we may never reach, never map, never understand. Perhaps beyond the cosmic horizon lies another realm, another structure, another universe, or perhaps it is something stranger still, something that predates space and time, something echoing from a forgotten cosmic cycle. Whatever it is, it's moving galaxies. And that means it's real. Black holes are perhaps the most terrifyingly beautiful entities in the cosmos. They are regions of space-time so warped, so dense, that not even light can escape their gravitational pull. From the outside, they appear as dark, silent voids, cosmic endpoints, where matter and energy disappear forever. But what if nothing ever truly disappears? What if black holes, instead of being the universe's great erasers, are its most enigmatic scribes? This is the information paradox of black holes, a contradiction at the heart of physics that questions whether the universe can ever truly lose information. And if not, what happens to everything that falls into these bottomless pits of gravity? According to quantum mechanics, information can never be destroyed. If you know the state of a system at one point in time, you should, at least in principle, be able to reconstruct its past and predict its future. This law is essential to the consistency of quantum theory, but black holes seem to break it. When something falls into a black hole, be it a star, a planet, or a single particle, its information appears to vanish from the observable universe. All that remains visible is the black hole's mass, charge, and spin. This is known as the no-hair theorem, suggesting that black holes are simple objects, indistinguishable from one another, except for these three properties. The unique characteristics of the things they consume, composition, structure, identity, are seemingly erased. But if that's true, and the information is destroyed, it violates quantum theory. This paradox reached a new level of urgency when Stephen Hawking proposed that black holes aren't completely black. Instead, due to quantum effects near the event horizon, they emit a faint glow, what we now call Hawking radiation. Over time, this radiation causes black holes to lose mass and eventually evaporate. But here's the problem. Hawking radiation is random. It carries no information about the matter that created the black hole. If a black hole evaporates entirely, and all that remains is this featureless radiation, then the information about everything it consumed is lost forever. Two of the most successful theories in physics, quantum mechanics and general relativity, are now at odds. One says information cannot be destroyed. The other describes a process that seems to destroy it. Both cannot be correct as currently understood. This has led to a frenzy of ideas and debates among physicists. Some propose that information is preserved at the event horizon itself, encoded in a two-dimensional surface that reflects the internal complexity of the black hole. This concept evolved into the holographic principle, which suggests that all the information contained in a volume of space can be described by information on its boundary. In this view, the black hole doesn't destroy information. It stores it on its surface, where it can, in theory, be recovered. Others speculate that information is encoded in the Hawking radiation itself, subtly woven into its quantum correlations in ways we don't yet understand. This idea supports the notion that black holes don't erase information. They scramble it beyond recognition, but keep it within the laws of physics. And then there's the boldest proposal of all, firewalls. Some theorists suggest that the smooth event horizon of a black hole may actually be a violent boundary, an inferno of quantum disruption that incinerates any information that dares to enter. But this idea contradicts general relativity's prediction that crossing the event horizon should be uneventful, until much later. Once again, two pillars of physics refuse to coexist. The information paradox of black holes is not just a technical disagreement. It touches on the fundamental nature of reality, whether the universe keeps a perfect record of everything that happens, or whether some truths are lost forever. Are black holes memory holes, or are they cosmic libraries written in a language we haven't yet learned to read? One thing is clear: whatever lies beyond the event horizon, it challenges the deepest assumptions about the universe. Perhaps one day, when we fully unify quantum, theory, and gravity, the paradox will resolve. Until then, black holes remain both the end of knowledge and its most tantalizing frontier. We go about our daily lives assuming reality is real, that the world around us, its colors, textures, sounds, and sensations, is grounded in something solid, external, and objective. But a growing number of scientists and philosophers are beginning to question that assumption. What if what we call reality isn't fundamental at all? What if we're living inside something designed, something coded, something simulated? This is the edge of simulation theory, the paradox that suggests the more we understand the universe, the more it starts to look like a construct rather than a creation. The idea isn't new. Philosophers have long toyed with the possibility that our senses deceive us. From Plato's cave to Descartes' evil demon, the notion that reality could be a projection or illusion has deep roots. But now, in an age of advanced computing and artificial intelligence, the question has taken on a literal edge. In 2003, philosopher Nick Bostrom famously proposed that one of the following must be true. Civilizations never reach a level of technological advancement capable of running universe-scale simulations. Advanced civilizations do exist, but choose not to run simulations. We are almost certainly living inside a simulation. The logic is unsettlingly elegant. If it's possible to simulate conscious beings, and if it becomes commonplace for civilizations to do so, then simulated realities would vastly outnumber real ones. Statistically speaking, the odds that we're in the one true reality shrink towards zero. But here's the paradox. We can't tell. Everything we know, all our observations, measurements, and experiences come from within the system. If the simulation is good enough, it will be indistinguishable from base reality. Even our science, quantum mechanics, relativity, thermodynamics, could be part of the simulation's rule set, and yet, cracks sometimes appear. The universe runs on mathematics. Beautiful, elegant equations govern everything from gravity to quantum interactions. Why should reality be so perfectly ordered? Why should particles behave like bits of information? Some physicists, like James Gates, have even found error-correcting codes embedded in the equations of supersymmetry. Codes remarkably similar to those used in digital computing. Is this just coincidence? Or are we seeing traces of a computational architecture? Another mystery lies in the quantum world. At the smallest scales, particles exist in a state of probability until they are observed. This raises an eerie question. If the universe renders reality only when it is observed, much like a video game only renders what's on screen, who or what is doing the observing? Simulation theory also provides a unique solution to the fine-tuning problem. The physical constants of the universe are incredibly precise. Tweak them slightly, and stars couldn't form, chemistry wouldn't work, life couldn't exist. This precision has led some to invoke a multiverse of endless variations. But simulation theory offers another explanation. Our universe is fine-tuned because it was programmed that way. But if we are simulated, who made us? That's where the edge of simulation theory begins to blur into theology. Is our programmer a godlike being? An alien intelligence? A post-human descendant running ancestor simulations? And more importantly, what is the purpose of the simulation? Is it an experiment, a game, a history lesson? Even if the theory is true, the simulation may be so vast, so stable, and so well designed that we are trapped within it, forever chasing answers from inside a digital dream. And yet, we question, we push, we probe. Because paradoxically, the very act of wondering whether we are simulated may be a feature of the simulation itself, an intended glitch, a philosophical safeguard, or simply a moment of awakening written into the code. The edge of simulation theory is not a conclusion, it's a boundary, a place where reason collides with speculation and where knowledge might dissolve into mystery. If we are inside a simulation, then even that question may be beyond our programming to answer. But if reality is code, perhaps truth is too. For centuries, humanity has looked to the stars and imagined an ultimate destination. We dream of exploring other galaxies, discovering alien civilizations, perhaps even reaching the edge of the universe itself. It's a narrative woven deeply into our culture. That space is a vast frontier, and that someday we will conquer it, just as explorers once crossed oceans. But what if this dream is an illusion? What if the edge we hope to reach isn't just far away? It's unreachable, not because of technology, but because it doesn't exist in the way we think. This is the paradox of the illusion of the final frontier. The realization that the more we understand about the universe, the more it seems to stretch endlessly ahead of us, receding faster than we can chase it. To begin with, consider the expansion of the universe. Not only is space expanding, but it's expanding at an accelerating rate, driven by the mysterious force we call dark energy. Galaxies are moving away from us faster over time, not because they are flying through space, but because space itself is stretching between us. As a result, the farther a galaxy is, the faster it recedes. Eventually, many of them will be moving away faster than the speed of light. This doesn't violate Einstein's theory of relativity because they're not moving through space faster than light. Space is expanding beneath them, but the effect is the same. They slip beyond our ability to ever reach them. We can see the light they emitted long ago, but we'll never be able to travel to them. They are retreating into cosmic silence, beyond interaction. This leads to a haunting idea. The observable universe is shrinking, not in size but in accessibility. Every day, more of the cosmos slips beyond our grasp. Stars, galaxies, entire clusters are vanishing from our future, forever beyond our reach, even in theory. So what, then, is the final frontier? If the universe has no edge, no boundary you can touch, no wall you can find, then exploration itself becomes a paradox. There is no frontier line to cross, only a horizon that recedes as we approach it, like a mirage on an infinite desert. Every advance in technology simply reveals more of what we cannot reach. Some physicists describe this in terms of cosmic event horizons, boundaries beyond which no signal can ever return. They are like black holes on a universal scale. Once something crosses the boundary, it's gone from our timeline forever. In fact, the entire universe may one day become like a supermassive black hole, with only a handful of gravitationally bound structures, like our local group of galaxies, remaining visible. Imagine a future where the stars we see today are gone, not destroyed, but pulled away so fast that their light can no longer reach us. A sky growing dimmer with every passing eon. A cosmos collapsing inward, not spatially, but informationally, until all that's left is our island of matter adrift. In a sea of darkness, this is not science fiction. This is mainstream cosmology, and it forces us to reconsider our obsession with frontiers. What if the real frontier is not out there, but within? What if the only journeys left are into the nature of consciousness, the structure of space and time, or the metaphysical boundaries of reality itself? Because the paradox is this: we have always imagined the frontier as a place, a destination. But in a universe with no edge, the frontier is not a line, it's an idea, one that moves as we move, staying forever just beyond reach. The more we chase it, the more we realize that we are not explorers pushing against a boundary. We are participants in an unfolding mystery with no final chapter. The illusion of the final frontier isn't just a limit of physics, it's a mirror. A reminder that some horizons are not meant to be crossed, but contemplated, and maybe, just maybe, the final frontier was never about space at all. In science, observation is everything. We measure, test, record, and conclude based on what we can observe. The entire framework of empirical knowledge rests on the assumption that reality reveals itself through observation, that the universe is accessible, at least in principle, to human inquiry. But what if that assumption is flawed? What if there are aspects of reality that by their very nature cannot be observed, yet still exist? This is the paradox of the observer of the unobservable, a haunting contradiction where the act of observation defines reality, but there may be realms forever closed to our perception, making the observer both the creator and the prisoner of knowledge. In quantum physics, observation plays a central and deeply mysterious role. The classic double slit experiment demonstrates that particles like electrons behave like waves when unobserved, creating interference patterns. But once observed, once we measure which slit the particle goes through, the wave function collapses, and the particle behaves like a discrete object. It's as if the universe waits for us to look before deciding what is real. But this raises a strange question. What happens in the absence of an observer? Does the universe exist in a state of pure potential until observed? And if so, who or what was the first observer? Did consciousness arise within the universe? Or did the universe require consciousness to come into being? Some interpretations of quantum mechanics, like the Copenhagen interpretation, leave the question open. Others, like many worlds, suggest that all possible outcomes occur in parallel branches, and observation merely determines which branch we experience. In either case, the observer plays a crucial, reality-defining role. Yet, the deeper paradox lies in the limits of observation itself. There are regions of the universe from which light will never reach us, due to cosmic expansion. There are dimensions, proposed in string theory, that are curled up so tightly, no probe can ever detect them. There may be multiverses, entire realms with different physical laws, eternally beyond our access. Even within our own reality, dark matter and dark energy comprise most of the universe, and yet we cannot see or interact with them directly. We infer their existence from indirect effects, gravitational pulls, cosmic accelerations, but we cannot observe them in the traditional sense. So how do we claim to know anything at all? We stand on a narrow ledge between what is measurable and what is meaningful. And the paradox is that our ability to observe is both our greatest strength and our deepest limitation. We define the universe through what we can observe, yet we know there must be more, perhaps infinitely more, that we never will. Some philosophers and physicists have speculated that the ultimate observer is not a person or a device, but consciousness itself. That subjective awareness is the lens through which the universe becomes real. If that's true, then perhaps the true frontier is not what we can observe in the world, but what we can awaken to within ourselves. But here lies the trap. If observation creates reality, and yet much of reality is unobservable, then we are trapped in a paradox of incomplete creation. We are observers of a universe that may never fully reveal itself, a mirror that only reflects back what we are capable of seeing. And yet, we continue to look. We send telescopes into deep space. We build particle colliders to glimpse the smallest particles. We meditate, theorize, imagine, because even as observers of the unobservable, we are driven by the mystery itself, not to solve it, but to experience it. Perhaps the paradox is the point. Perhaps the universe isn't a puzzle to be solved, but a question to be lived. And we, observers standing at the edge of the unseeable, are not meant to find all the answers, but to marvel that the questions exist at all. In the vastness of the cosmos, we often search for answers. Answers to where we came from, what we're made of, and why anything exists at all. We build telescopes to peer into the birth of galaxies, create machines that split atoms apart, and write equations to explain the fabric of reality. But with every breakthrough comes a deeper question, a new uncertainty, a more profound paradox. The mysteries we've explored in this journey are not just scientific puzzles. They are mirrors, reflections of our own limitations, curiosities, and dreams. They challenge the very core of what it means to observe, to understand, to exist. From the paradoxes of time and consciousness to the silence of the cosmos and the invisible structures that shape it, we are reminded of one fundamental truth. The universe is not obligated to make sense to us, and yet we continue to seek, because there is something deeply human about gazing into the unknown. We are not just creatures of biology, we are vessels of wonder. The stars above may be unreachable, and the edges of existence may be forever out of sight. But the act of asking, of wondering, brings us closer to something timeless. The more we learn, the more we realize how much remains in shadow. But in those shadows lie beauty, possibility, and the quiet promise that the greatest truths are not answers to be found, but questions that awaken us. So as you drift into sleep, let these paradoxes whisper to your soul. Let them remind you that you are a part of this cosmic riddle, not apart from it. You are the observer and the observed, the question and the dream, and the universe. It listens in silence.